In 1969, a physicist named Joseph Weber told the world he had heard the universe ring. He was an unlikely person to hear anything. As a boy in Paterson, New Jersey, he was hit by a bus and lost the ability to speak, and he had to be taught how to talk again, one sound at a time, by a stranger leaning over him. He grew up, survived the sinking of his aircraft carrier in the Pacific, and then built a 2-ton cylinder of solid aluminum, sealed it in a room in Maryland, and swore he could feel it trembling with the death of stars at the center of the galaxy. For about 5 years, almost every physicist alive believed him. Then, they took the discovery apart. And then, they took him apart with it. He spent the last 25 years of his life as what one newspaper called a pariah, paying for his own laboratory, sweeping its floor himself, certain he was right, while the field he had personally founded spent more than $1 billion building the machine he had dreamed of, and quietly made sure his name was nowhere near it. He died in the year 2000, 15 years before that machine finally heard the universe ring for real. The cruelest part is not that he was wrong, it is that he was wrong and right in the same breath, and there was never one moment in his life when he could have told which. So settle in, get comfortable, and if you have not already, subscribe or join so the next one of these finds you when it drops. There is also a Patreon, where these descents run longer and wander further out, through space, time, physics, and the quieter catastrophes most channels never sit with. Stay to the end, because the question of whether Joseph Weber ever heard anything at all does have an answer, and the only person who could give it. The woman who was married to him for 28 years could only manage 3 words. Let's start where it started. There is a cylinder of solid aluminum, about 2 tons of it, roughly the length of a grown man lying down, that a physicist named Joseph Weber swore he could hear ringing. Not ringing the way a struck bell rings, ringing the way he believed the universe itself rings when something enormous dies somewhere far away. The collapse of a star, the merger of 2 dead suns, something violent enough, at the center of our galaxy 30,000 light-years from here, to reach across all that empty space and squeeze a block of metal sitting in a laboratory in Maryland by a distance smaller than the width of a single proton. He built the cylinder. He wired it with crystals that turned the faintest tremor into a voltage. He cooled the room, isolated it from trucks and footsteps and weather, and he listened. And for about 5 years, from 1969 into the early 1970s, almost every physicist on Earth believed he was hearing it. He was not hearing it. The signal that Joseph Weber gave his name, his reputation, his marriage, his funding, and the final 3 decades of his life too, was, as far as every piece of evidence we have can tell us, never there at all. He was listening to noise. He was listening to the random thermal jitter of the atoms in his own apparatus, and to the ordinary accidents of a machine running long enough to fool anyone, and somewhere in that noise he heard the galaxy dying, and he could not be talked out of it. Not by the most respected experimental physicists in the world, not by a decade of laboratories that built copies of his machine and heard nothing. Not by an error so specific and so damning that when it came out, it ended his standing in physics in a single afternoon. He went to his grave certain. And the cruelest detail, the one that I keep coming back to, is that he died 15 years before the machine that finally did hear the universe ring proved that the thing he had been listening for was real. So here is the version you have probably absorbed without ever being told it directly. In September of 2015, a pair of enormous detectors confirmed that gravitational waves are real. Einstein was right. Science worked. 100 years of theory paid off in a clean, triumphant signal. and 3 men collected a Nobel Prize for it 2 years later. That is true. Every word of that is true. But it is the version assembled for the press release, and underneath it is a story that the press release cannot hold, because the press release needs a hero, and this story does not have one. It has a man who was the founding father of the entire field of gravitational wave detection, a man whom the people who won that Nobel Prize will tell you, without being asked, that none of their work exists without. And that same man spent the back half of his career as what one newspaper literally called a pariah, defunded, mocked at conferences, running a concrete shed in the woods as both its chief scientist and its janitor, defending a discovery that was almost certainly never real. And here is the part I want you to sit with, because it is the thread that runs underneath everything that follows. From the inside, a real detection and a complete delusion can feel exactly the same. There is no light that comes on. The universe does not send a receipt. When Weber looked at his data and saw the galaxy, and when, decades later, a team of 1,000 people looked at their data and saw 2 black holes, the difference between those 2 moments was not that one of them felt more certain. Weber was certain. The difference is something much harder to look at directly. And getting to the bottom of it is going to take us through the most bitter feud in the history of modern physics, through a paper Einstein himself wrote trying to prove that gravitational waves do not exist, through a confrontation at an academic conference that nearly turned into a fistfight and was broken up by a polio survivor holding up his cane, and finally to a control room in 2015 where the first thing the scientists did when they saw the signal of the century was assume, out of hard institutional fear, that one of their own colleagues had faked it. You need to understand who Joseph Weber was before any of this, because the shape of the man is the shape of the tragedy, and the 2 are not separable. He was born in Paterson, New Jersey, on the 17th of May, 1919, the youngest of 4 children of Jewish immigrant parents who spoke Yiddish at home and arrived in America with almost nothing. His given name was Yonah. His father had no birth certificate for him and had taken the surname Weber in the first place only because it matched an available passport. When Joseph was 5 years old, he was struck by a bus and lost the ability to speak. He had to be retrained, sound by sound, by a speech therapist, and when his speech came back, it came back without the Yiddish inflection he had been born into and with the flat, plain mid-American accent of the woman who taught him to talk again. His family started calling him Yankee. I am not going to pretend that detail is incidental. Because of everything I read about this man, it is the one that will not leave me alone. A boy loses his voice, has it reconstructed for him from nothing by a stranger leaning over him repeating sounds, and grows up to build a machine whose entire purpose is to give the universe a voice it has never had. To take the silent stretching of space and turn it into something a human being can finally hear. The personal and the physical are not 2 separate threads here. They are the same thread, running in both directions, and we are going to feel it pull tight at the end. He was poor, and he was brilliant, and he was relentless, and those 3 facts steered his whole early life. He graduated from the mechanical arts track at Paterson East Side High School in 1935, just after he turned 16. He started at Cooper Union, then won admission by competitive examination to the United States Naval Academy, partly to spare his family the cost, and he graduated from Annapolis in 1940 with a commission. This is the part of his life that most accounts skip past in a sentence, and it should not be skipped, because the man who would later refuse for 30 years to admit he might be wrong had already, by his mid-20s, survived something that recalibrates a person permanently. He was assigned to the aircraft carrier USS Lexington. The Lexington steamed out of Pearl Harbor on the 5th of December, 1941. 2 days later, the Japanese attacked Pearl Harbor, and Weber's ship was not in it because it had already left. 5 months after that, on the 8th of May, 1942, at the Battle of the Coral Sea, the Lexington was hit, caught fire, and was abandoned and sunk. Joseph Weber survived the sinking of his ship. He went on to command a submarine chaser during the invasion of Sicily in 1943. He ran the Navy's electronic countermeasures section. He came out of the war in 1948 as a lieutenant commander, an engineer who had spent his formative years around radar and the practical hard edges of making instruments detect things that other people insisted could not be detected. That is the man who walked into the University of Maryland in 1948 at the age of 29 and took a job as a professor of electrical engineering for what he later recalled, with a kind of pride, as the princely sum of $6,500 a year. The job came with a condition. He had to go and earn a doctorate in physics. So he did. And here begins the pattern that defined his entire career, a pattern so consistent it starts to feel less like bad luck and more like a curse, and it is the first of the things I want you to hold open in your mind, because we will close it much later and it will hurt more then. Weber had a gift for being early, not wrong, early, which in science can be worse than wrong, because being wrong gets you forgotten, and being early gets you blamed. He went looking for a thesis problem and approached George Gamow, one of the towering physicists of the century, the man who would help predict the leftover radiation from the Big Bang. Gamow's entire response, when Weber asked him for a problem to work on, was the single word no. Think about the size of the door that closed in that one syllable. Gamow was a microwave man. Weber was a microwave engineer, and the cosmic microwave background, the faint glow left over from the birth of the universe, was sitting there a decade away from discovery, waiting for exactly that pairing of skills. Weber got a no and went elsewhere and earned his doctorate in physics from the Catholic University of America in 1951. And in that same stretch of years, around 1951 to 1953, Weber did something genuinely visionary. He worked out and publicly described the principle of the maser, the device that amplifies microwaves by stimulating emission from excited atoms, the direct ancestor of the laser. He presented it. It is in the record. And the Nobel Prize for that line of work went, in 1964, to Charles Townes and to two Soviet physicists, Basov and Prokhorov. Not to Weber. He was early. He had the idea. He put it into the air, and the recognition formed somewhere else, around someone else, the way condensation chooses one surface over another for no reason the water can explain. So before gravitational waves ever entered the story, Joseph Weber had already come within arm's reach of 2 Nobel Prizes and walked away from both with nothing. The cosmic background, gone in a single no from Gamow. The maser, gone to other names. A lesser man, or maybe a wiser one, would have read those near misses as a warning. Weber read them as unfinished business. And in 1955, on a sabbatical that he spent working with one of the most important physicists alive, he found the third near miss, the one that would consume the rest of his life. But to understand why it consumed him, and why it was a far stranger thing to chase in 1955 than you would ever guess from the clean confidence of the 2015 announcement, you have to understand that the very thing Weber set out to detect was something that the man who invented the idea had himself, at one point, tried to publish out of existence. Because Einstein did not believe in gravitational waves either. Not consistently. Not at the end. Here is a thing you were probably never told, and it is the first of the misconceptions that I think actually matters, because it changes how you read everything Weber did. The popular story is that Einstein predicted gravitational waves in 1916, confidently, as a clean consequence of general relativity, and that physicists then spent a century building better and better instruments to confirm the obvious. That is not what happened. Einstein himself was deeply unsure whether gravitational waves were real physical things or just an artifact of the mathematics, a ripple in the bookkeeping rather than a ripple in space-time. And in 1936, 20 years after the original prediction, he became convinced they did not exist at all. He wrote a paper that year with his assistant Nathan Rosen. The title was a question, and the question was the whole point. It was called, "Do gravitational waves exist?" Their answer, worked out from a particular solution to his own field equations, was no, they did not. Einstein submitted this paper to the journal Physical Review, the most important physics journal in America, fully expecting it to be printed. And then something happened to Einstein that had essentially never happened to him before in his life. The editor, a man named John Tate, did not simply publish it. He sent it out for peer review to an anonymous referee, and the referee read it carefully and came back with a 10-page report explaining in detail that Einstein was wrong, that the conclusion rested on a mathematical mirage, a feature of the particular coordinates he had chosen that vanished the moment you described the same physics a different way. The singularity Einstein thought he had found, the thing that supposedly proved the waves could not exist, was not a real feature of space-time. It was an accident of the math. Einstein was furious, not because he had been shown to be wrong, he did not yet accept that he had been, but because he had been subjected to review at all. He wrote back to the editor a letter that has survived, and the tone of it is something to behold from the most famous scientist who ever lived. He said in essence that he and Mr. Rosen had sent the manuscript for publication and had not authorized the editor to show it to anyone before it was printed, that he saw no reason to address the in any case erroneous comments of an anonymous expert, and that on the basis of this incident he would prefer to publish elsewhere. And he did. He pulled the paper. He never published in Physical Review again for the rest of his life. He sent a revised version to a smaller journal instead. And the part that should make you smile and wince at the same time is what came next. The anonymous referee was a cosmologist named Howard Percy Robertson, and Robertson did not gloat and did not go public. He quietly befriended Einstein's new assistant, a young physicist named Leopold Infeld, and over conversations, without ever revealing that he had been the referee, he walked Infeld through the error. Infeld took it to Einstein, and Einstein, to his enormous credit, looked again, saw it, and reversed himself before the revised paper went out. He even added a note thanking a Professor Robertson for his assistance, never knowing, or never letting on that he knew, that Professor Robertson was the very man whose report had enraged him. The waves were back. But notice what just happened. The single most authoritative mind in the history of gravitation had, 2 decades after predicting these things, talked himself into believing they were fictional, submitted that belief for publication, and been saved from printing it only by a peer reviewer he tried to ignore. If Einstein could not keep a steady grip on whether gravitational waves were real, what exactly was a Navy engineer from Paterson supposed to be detecting? That question did not get a firm answer until 1957 at a conference in Chapel Hill, North Carolina, and the answer came from Richard Feynman in a form so simple that it is still how physicists settle the argument today. The deep worry, the thing that kept the reality of gravitational waves in doubt for 40 years, was whether they actually carry energy. A wave that carries no energy can do no work, and a wave that can do no work cannot be detected, and a thing that cannot in principle be detected sits in an uncomfortable gray zone between real and not real. Feynman cut through it with what is now called the sticky bead argument. Imagine a rod with two beads on it, free to slide, but with a little friction. When a gravitational wave passes, it stretches and squeezes space along the rod, and the beads, being free, move differently than the rod itself does. They slide. And if they slide against friction, they generate heat. Heat is energy. If the wave can warm a bead, the wave carries energy, and if it carries energy, it is real, and it can, in principle, be caught. Feynman, who had registered at the conference under a fake name because he thought the field of general relativity had become a swamp of people arguing about nothing, had just handed that field the argument that made the entire enterprise of detection legitimate. And sitting in that room at Chapel Hill in 1957, listening, was Joseph Weber. This is not a story he reconstructed later. He was there. He had already spent his 1955 sabbatical working on the theory of gravitational radiation alongside John Archibald Wheeler, the man who would later coin the term black hole, partly at the Institute for Advanced Study in Princeton. And the two of them produced foundational theoretical work on how such waves would behave. Weber wrote the first textbook on the subject, General Relativity and Gravitational Waves, published in 1961. So when Feynman stood up and effectively said these waves are real and they carry energy and therefore they can be detected, Weber was not a spectator receiving permission. He was the one man in the world already asking the next question, the one nobody else thought was worth asking. The question that Wheeler would later put in his autobiography in a single sentence. Wheeler wrote that no one else had the courage to look for gravitational waves until Weber showed that it was within the realm of the possible. Within the realm of the possible. Hold those words against the actual numbers, because this is where the real horror of what Weber attempted comes into focus. And it is a horror of scale that no one had the tools to fully appreciate in 1960. A gravitational wave does not push on things. It changes the distance between them. As it passes, it stretches space in one direction and compresses it in the perpendicular direction, and then reverses over and over at the frequency of the wave. The amount of stretching is described by a number physicists call strain, which is just the fractional change in length, how much a given distance grows or shrinks divided by the distance you started with. And the strain produced at the Earth by even a violent astrophysical event, the kind of thing Weber was hoping to catch, is around 1 part in 10 to the 21. I am going to make that concrete because the number is meaningless until you do. 1 part in 10 to the 21 means that if you had a ruler as long as the entire distance from the Earth to the nearest star beyond the Sun, about 4 light years, a passing gravitational wave would change that enormous length by about the width of a human hair. That is the signal. That is what is actually arriving. A stretching so faint that across the width of Weber's 2-ton cylinder, it amounts to a length change far, far smaller than the diameter of a single proton, the tiny particle at the heart of an atom. Now hold that against what his instrument could actually feel. Weber's bar was a cylinder of aluminum suspended on a wire inside a vacuum tank, isolated as well as 1960s engineering allowed from every other source of vibration. Around its waist, he bonded piezoelectric crystals, materials that produce a measurable voltage when they are squeezed even slightly. The bar had a natural ringing frequency, the note it would sound if you could strike it, of about 1,660 cycles per second. And he chose that frequency on purpose, because the gravitational radiation from a collapsing star was expected to peak right around there. The idea was sympathetic resonance, the same reason a wine glass sings when you find the exact pitch that matches it. A gravitational wave at the right frequency would, in theory, set the bar ringing, and the crystals would turn that ringing into a signal he could record. It was an elegant idea, and it was, for its time, an astonishing piece of instrumentation. The problem was never the elegance. The problem was a wall, a noise floor that no amount of elegance in 1969 could get under. And here is what the cautionary tale version of Weber leaves out, the thing his harshest critics never disputed even at the height of the feud. Nobody handed him any of this. There was no field of experimental gravitational wave detection for him to join, because he was inventing it as he went. There was no established way to isolate a 2-ton bar from the ceaseless tremor of the planet, so he worked one out. There was no accepted method to read out a vibration smaller than an atomic nucleus from a block of metal, so he pioneered the use of piezoelectric crystals to do it. There was no agreed analysis for pulling a brief event out of a continuous stream of thermal noise, so he wrote one. And the fact that his analysis later turned out to be too aggressive does not change the fact that he had to build it from nothing because nothing existed. He was a Navy radar engineer who taught himself general relativity, wrote the first textbook on the subject, and then sat down and tried to construct, with the tools of the 1960s, an instrument to feel the faintest force in the known universe. Richard Garwin, the man who would later destroy him, never questioned that Weber was a serious and gifted experimentalist. That was precisely why the result had to be taken seriously enough to be torn apart. You do not assemble a worldwide effort to refute a crank. You assemble it to refute a founder who might be wrong. And the trouble with refuting a founder is that when you are finished, you have refuted the founder, and you still have to live in the field he founded. That wall was heat. The atoms in a 2-ton block of aluminum at room temperature are not still. They jitter, constantly, randomly, with thermal energy, and that jitter makes the bar quiver on its own all the time, completely independent of anything happening in the cosmos. And the size of that thermal quivering was such that Weber's bars could only reliably register strains of around 1 part in 10 to the 16. Compare the two numbers. The bar could feel a strain of 10 to the minus 16. The real waves arriving from space carry a strain of about 10 to the minus 21. That is a gap of 5 orders of magnitude. 5 zeros. The bar was roughly 100,000 times too insensitive, in strain, to feel what nature was actually sending. To put that gap in terms you can hold, imagine 2 people are asked to measure the distance from New York to Los Angeles. One of them reports a number that is off by the width of a hydrogen atom, and the other one cannot even tell you the answer to within 100,000 of those errors. Weber was the second person, holding a ruler that could not resolve what he was trying to read, insisting that he could read it anyway. This is the fact that sits underneath the entire tragedy, and it is not a matter of interpretation. It is not a thing reasonable people disagree about. It is arithmetic. The bars could not have detected the sources Weber claimed they detected. The physics forbids it. And yet, and this is the part that I genuinely did not understand until I had been reading about it for a long time. The gap I just described was not obvious in 1969. Nobody had a confirmed detection to calibrate against. Nobody knew for certain how strong the real signals were, or how often they came. The theorists had estimates, but estimates were exactly the thing under dispute. So when Weber announced that his bars were ringing, the field could not simply point at a number and say that is impossible. They had to argue their way there, slowly, painfully, over years, and in the meantime, the most natural thing in the world happened. The thing that happens whenever an instrument detects something that the theory says should be far too faint to detect. The world did not assume he was wrong. The world assumed the universe was louder than the theorists thought. For a few years, the most exciting possibility in physics was that Joseph Weber had not just detected gravitational waves, he had detected that the galaxy was full of them. I want you to feel the brief, strange brightness of those years, because it makes everything that comes after so much darker by contrast. And because it is the only stretch of his life in which the world gave him what he had earned. For a window of roughly 5 years, Joseph Weber was not a pariah. He was a star. His name moved through physics departments the way the names of the great theorists did, except that he was an experimentalist, a builder, a man who had done the thing rather than merely predicted it. Conferences wanted him. Younger physicists, the ones who would later run the laboratories that buried his result, came into the field because of him, drawn by the romance of a man listening to the galaxy with a cylinder of aluminum in a shed. He was invited to give the talks that define a discipline. He had 2 near misses behind him. The cosmic background lost to Gamo's single no, and the Mesa handed to other names. And now, at last, in his 50th year, it looked as though the third time was going to be different. It looked as though he was finally going to be the one standing in the doorway when the recognition arrived, instead of the one who had just stepped out. And the cruelty of that brightness is that it was not a delusion he manufactured alone in a room. The whole field shone it on him. They believed him. They put him on the covers and in the lectures and at the head of the table, and then, when the energy argument and the replications and the 4-hour error came in, the same field that had elevated him had to climb back down off the position it had taken. And there is nothing a community resents more than the man who made it look foolish for having believed him. Part of the venom that came later was the venom of people embarrassed by their own earlier enthusiasm. He had not fooled only himself. For 5 years he had fooled almost everyone, and almost everyone needed afterward to decide that the fooling had been entirely his fault, because the alternative was to admit how badly they themselves had wanted the galaxy to be ringing. The descent when it came was steeper for having started so high. A man who is ignored from the beginning is merely overlooked. A man who is crowned and then dethroned is humiliated, and the memory of the crown is what makes the dethroning unbearable. Therefore, the question that should have been asked first, before any of the fame, was the simplest and the most brutal one. If the bars are ringing this often, where is all that energy coming from? And when somebody finally did the arithmetic on that question, the answer was not that Weber was slightly off. The answer was that if he was right, the galaxy should already be dead. But that arithmetic came later. In 1969, it had not been done yet. And what the world saw instead was a paper that landed like a thunderclap. On the 16th of June, 1969, Physical Review Letters, the fast publication channel for the most important results in physics, printed a paper by Joseph Weber with a title that did not hedge. It was called Evidence for Discovery of Gravitational Radiation, not evidence for possible signals, not anomalous excitations consistent with. Discovery, the abstract told the world that coincidences had been observed on gravitational radiation detectors separated by a baseline of about 1,000 kilometers. One detector at the University of Maryland and another at Argonne National Laboratory near Chicago, and that the probability that all of these coincidences were accidental was, in his words, incredibly small. The logic of the setup was genuinely clever, and you have to give him this, because it is the thing that made him so hard to dismiss. A single bar ringing tells you nothing, because a single bar rings constantly from its own thermal noise, from a truck passing outside, from a door slamming, from the building settling. But 2 bars, one in Maryland and one 1,000 kilometers away in Illinois, should not ring at the same instant from local causes, because a truck in Maryland does not shake a tank in Illinois. If both bars jumped at the same moment again and again, the only thing big enough to hit them both simultaneously was something coming from outside, something passing through the whole Earth at once. A gravitational wave. He recorded the output of both detectors, lined up the timing, and counted the moments when they spiked together. He found roughly 24 such coincidences over about 81 days. He found, by his count, about one event per day where the universe seemed to ring both bells at once, for a window of about 5 years. This made Joseph Weber arguably the most important experimental physicist alive. He was on the cover of magazines. He was the man who had heard the universe. Physicists who had spent their careers being told gravitational waves were undetectable in principle now had a colleague claiming to detect them daily with a machine you could walk up and put your hand on. And then, in 1970, he made the claim that turned excitement into something closer to awe. And, also, though almost nobody noticed it at the time, planted the seed of his destruction. He published a follow-up, including a paper in Physical Review Letters titled Anisotropy and Polarization in the Gravitational Radiation Experiments, in which he reported that the coincidences were not arriving randomly through the day. They peaked. And they peaked on a 24-hour cycle that was not tied to the sun, but to the stars, what astronomers call sidereal time. The slightly shorter day, defined by the Earth's rotation relative to the fixed background of the galaxy, rather than relative to the sun. And the direction the peaks pointed toward was the center of the Milky Way. Understand why that was so overwhelming as a piece of evidence, because it is the reason serious people believed. Local noise has no reason to care about the position of the galactic center in the sky. Electrical interference, weather, seismic rumbling, none of it follows sidereal time. But a source of gravitational waves sitting at the heart of the galaxy would sweep across the sky once per sidereal day as the Earth turned, and the bars would respond most strongly when that source was best aligned with them. Weber reported that the effect exceeded 6 standard deviations, a level of statistical significance that in physics is the gold standard for a real result. He had, it seemed, not only detected gravitational waves, he had triangulated their source. He had pointed at the center of the galaxy and said, "It is coming from there," and the heart of our galaxy, with its 10 billion suns worth of mass, was exactly the kind of place violent enough to make them. This should have been one of the great triumphs in the history of science. And for a brief moment it was treated as one. Therefore it is worth slowing down to notice how fast, and from what an unexpected direction, the first crack appeared, because it did not come from an enemy. It came from a room full of people who wanted him to be right. The story, as the physicist Tony Tyson told it, took place at a colloquium where Weber presented this galactic center result, with John Wheeler and Freeman Dyson, two of the most formidable minds in physics, sitting in the front row. And as Weber explained that the signal peaked once per sidereal day, pointing at the galactic center, the room did a piece of arithmetic in real time and rose to its feet almost together. Because gravitational waves, as everyone in that room knew, pass straight through the Earth. The planet is no obstacle to them. They go through it as if it were not there. Which means that a bar should ring whether the galactic center is high overhead or on the far side of the planet beneath your feet, because the waves reach the bar from below just as easily as from above. The signal should peak not once every 24 hours when the source is overhead, but twice every 12 hours. Once when it is above you and once when it is directly below. Weber had reported a once-a-day peak. The physics demanded a twice-a-day peak. His own evidence, the sidereal pointing he was so proud of, contradicted the very thing he was claiming to detect. And here is the moment that, more than any single equation, turned the careful physicists against him. And I want to be precise about why, because it is subtle and it is the hinge of the whole tragedy. Weber went away. He reanalyzed his data, and within a couple of weeks he came back with clusters of events appearing every 12 hours, the pattern the theory now demanded. To a sympathetic eye, that looks like a man correcting an analysis. To the increasingly unsympathetic eyes in that field, it looked like something far more disturbing. It looked like the data would say whatever Weber needed it to say. First it pointed once a day, and when once a day was shown to be impossible, it pointed twice a day instead, and the same noise had obligingly rearranged itself to match the new requirement. The signal was not constraining the theory was sculpting the signal. And once you have seen an analysis bend that smoothly to fit whatever answer is wanted, you can never again fully trust that the answer was ever in the data at all, rather than in the hands of the person analyzing it. That is the thing that began to spread through the field, quietly at first. Not he is wrong, something worse. He cannot tell the difference between finding a signal and producing one. But the deepest problem, the one that turned a methodological worry into a physical impossibility, was the energy. And this is where the theorists finally did the arithmetic that should have been done on day one. Ask the simple question. If the center of the galaxy is producing gravitational waves strong enough and frequent enough to ring a hopelessly insensitive 2-ton bar in Maryland about once a day, how much energy is that source pouring out? The waves spread out in all directions, getting fainter with distance, so to still be detectable after 30,000 light years, they had to start out almost unimaginably powerful. When physicists ran that calculation, the number that came back was not large. It was absurd. To feed Weber's detection rate, the galactic center would have to be converting the equivalent of something like 1,000 suns, entire stars, completely into gravitational radiation, every single year. The astrophysicists Dennis Sciama, Martin Rees, and George Field worked through what that meant. And the meaning was a sentence that should have ended the discussion. The galaxy could not survive it. A source bleeding mass into gravitational waves at that rate would drain the entire mass of the Milky Way in a cosmological eye blink, on a timescale enormously shorter than the known age of the galaxy. But the galaxy is still here. It is roughly 13 billion years old, and it is still full of stars. So either the galaxy had been pouring 1,000 suns a year into gravitational waves for billions of years, which would have evaporated it many times over, or Weber's detection rate was impossible. There was no third option. A German physicist named Peter Kafka captured the whole thing in the title of an essay he wrote, a title that is half joke and half indictment. He called it Are Weber's Pulses Illegal? Not illegal as in against the rules of a journal, illegal as in forbidden by the conservation of energy itself. And Richard Garwin, a man who is about to become the central antagonist of this story, put it in the bluntest terms anyone used. He said the model was insane, because if you were really detecting what Joe Weber claimed to be detecting, the universe would convert essentially all of its energy into gravitational radiation in something like 50 million years. The lights would already be going out. The fact that they are not is the proof. So by the early 1970s, the situation was this. The most famous experimental result in physics rested on signals that were too frequent to be possible, pointing in a direction that contradicted the physics of the very waves being claimed, produced by an analysis that seemed able to find whatever it was looking for. And every word of that critique was theoretical. Calculations, arguments, objections in principle. None of it touched the actual machines. Weber could, and did, simply answer that the theorists did not understand his instrument. that the energy estimates relied on assumptions about the sources that might be wrong, that perhaps the radiation was beamed toward us rather than spread evenly, reducing the total energy required. He had an answer for everything, and as long as the only weapons against him were arguments, he could parry them. To actually break him, somebody was going to have to do the one thing he was sure no one else could do as well as he could. Somebody was going to have to build the machine, run it honestly, and listen. And when they did, what they heard, across laboratory after laboratory, on 3 continents, was nothing at all. The laboratories came one after another, and you should hear them as a list, because the accumulation is the point. At IBM, the physicist Richard Garwin, one of the most brilliant and most feared experimentalists in the country, the man who had designed the first hydrogen bomb at the age of 23, built a detector with his colleague James Levine. They ran it for 6 months. In 6 months, it registered exactly 1 pulse, most likely noise, and they published their negative result in Physical Review Letters in 1973. At Bell Laboratories, Tony Tyson built a larger, carefully calibrated bar and watched it for months, and saw nothing that looked like a signal. In Moscow, Vladimir Braginsky, a meticulous Soviet experimentalist, built detectors and found nothing. In Munich, Heinz Billing and his group at the Max Planck Institute built bars matched closely to Weber's own frequency and found nothing. In Glasgow, Ronald Drever, a man who will matter enormously at the end of this story, built detectors and found nothing, and concluded the real rate of gravitational wave events had to be far too low to account for what Weber claimed. There were groups at Rochester, at Tokyo, at Stanford, Bell, IBM, Moscow, Munich, Glasgow, Rochester, Tokyo. Count them. Not one of them, anywhere on Earth, could reproduce Joseph Weber's result. And in science, a result that no one else can reproduce is not a result. It is a story one laboratory is telling about itself. You should understand who Richard Garwin was, because the man who took it upon himself to end Weber was not some minor skeptic looking to make a name. He was, at the time, one of the most consequential physicists in America, a polymath who had designed the working hydrogen bomb as a graduate student in his early 20s, who advised presidents, who held patents across a dozen fields, a man Enrico Fermi reportedly called the only true genius he had ever met. When a person like that decides that a result is not merely wrong, but a contaminant in the literature that must be removed, he does not write a careful, hedged rebuttal. He goes to war. And the war between Garwin and Weber spilled out of the conference halls and onto the pages of Physics Today, the journal that every working physicist reads, in an exchange of letters across 1973 and 1974 that was about as close to a public knife fight as the genteel surface of physics permits. Weber answered every charge. He published detailed defenses, including a long technical paper in 1976, methodically responding to his critics. He never conceded a single point. And that is the thing that turned a scientific disagreement into something that felt, to the people watching, almost like a tragedy unfolding in real time. Most wrong results die quietly, abandoned by their authors once the evidence turns. Weber would not let his die. He defended it with the same ferocity he had once used to build it, and the longer he defended it, the more the field stopped seeing a colleague who had made an error and started seeing a man who could not be reasoned with, which is a far more dangerous thing to be in a community that runs entirely on the assumption that everyone can eventually be reasoned with. Weber's response to this was the response that, more than anything, defines the back half of his life. He did not concede. He maintained that the other groups were doing it wrong, that their detectors were less sensitive than they claimed, that their analysis was too crude to pull the signal out of the noise the way his could. And there was a sliver of legitimate science buried in that defense, which is what made it so hard to simply dismiss. His analysis really was different from everyone else's. The other groups used what is called a linear algorithm to process their data, a straightforward method. Weber used a non-linear method, a more aggressive technique that he argued was more sensitive to the kind of brief pulses gravitational waves would produce. He was, in effect, saying that his special way of listening could hear things their ordinary listening missed. The trouble is that an aggressive non-linear method that can pull faint signals out of noise is also an aggressive method that can manufacture faint signals out of noise, and from the data alone, it can be nearly impossible to tell which one is happening. Which brings us to the thing that I think is the genuine intellectual heart of this entire story, the thing that outlives Weber and reaches forward across 40 years to haunt the people who finally succeeded. There is a trap built into the structure of experimental science, and the sociologist Harry Collins gave it a name. He called it the experimenter's regress, and he developed the idea by spending decades, starting in 1972, embedded in the gravitational wave community, watching this exact fight unfold. The trap is this. How do you know if you have built a good detector? A good detector is one that detects gravitational waves, so you build it, and either it detects them or it does not. But wait, how do you know whether gravitational waves are even there to be detected in the first place? You know, because a good detector detects them. Do you see the circle? To know if the detector works, you need to know the answer it is supposed to give you, and to know the answer, you need a detector that works. When nobody yet knows the true answer, there is no clean, independent, purely technical way to decide whose apparatus is functioning correctly. Weber says his bars detect waves, and the others are too insensitive. The others say their bars are sensitive enough, and Weber is fooling himself. And there is no neutral referee made of pure logic that can step in and settle it, because the only referee that could settle it is a confirmed detection, which is the very thing in dispute. The argument cannot be closed by data alone. It gets closed, Collins observed, by something messier, by reputation, by persuasion, by who builds alliances, by which account the community decides to believe. The science is real, but the closing of the argument is also social. And once you absorb that, you cannot unsee it, and it should disturb you, because it means the line between a discovery and a delusion is not always drawn by nature. Sometimes it is drawn by us afterward, and we tell ourselves nature drew it. Remember that, because in 2015, the people who finally caught the wave were so afraid of this exact trap that they built a machine inside their machine for the sole purpose of lying to themselves on purpose, to find out whether they could be fooled. We will get there. For Weber, the closing of the argument came in two blows, one slow and one sudden. And the sudden one happened in a single room on a single afternoon in 1974. The slow blow came first, from a physicist named David Douglas at the University of Rochester, who got access to the details of Weber's data analysis and found something wrong in the computer program itself. The exact nature of the flaw is technical, involving how the algorithm handled the timing and phase of the signals. But the consequence was not technical at all. The program could generate apparent coincidences out of pure noise. It could make a signal seem to climb up out of randomness that contained no signal. And then came the blow that no defense could survive. The one that turned a dispute about sensitivity into something that looked, to the watching field, like outright self-deception. Weber had agreed to a joint analysis. His Maryland data and Tony Tyson's data would be compared directly, looking for coincidences between the two independent groups, the cleanest possible test. And when the records were lined up, it emerged that the two teams had been recording their data using different time standards. One group was logging events in Greenwich Mean Time, the international standard, and Weber's clock was set differently. And the result was that the two data streams were offset from each other by about 4 hours. The timestamps did not correspond. An event marked at a given moment in one record was actually being compared against a moment about 4 hours away in the other. And Weber's analysis still found coincidences. It found simultaneous events in two recordings that were not, in fact, simultaneous, that were separated by 4 hours, which is to say it found gravitational waves arriving at the same instant in data where the same instant did not even line up. There is only one thing that can produce a coincidence between two recordings that are 4 hours out of step: chance, dressed up by an analysis method willing to call chance a signal. And it got worse, in a way that I find almost unbearable to recount, because it removes the last possible charitable interpretation. Tony Tyson, suspicious, had quietly inserted fake signals into his own data stream, artificial pulses that he knew were not gravitational waves, as a test. And Weber's analysis found coincidences with those too. It detected agreement between Marilyn's real bar and pulses that Tyson had invented and injected by hand. As the physicist and writer Jana Levin put it, he could find coincidence anywhere. Wherever he looked, the method delivered the signal the method was built to deliver, whether the other side of the comparison was a distant detector, a 4-hour mismatch, or a handful of fictions a colleague had typed into a file to catch him out. David Douglas found the 4-hour error and took it to Weber, and what happened next determined everything. Weber considered the situation and did not issue a retraction. He did not stand up and say, "The timing was off, the coincidences are not real, I was mistaken." He defended the work, and that refusal is what moved Richard Garwin from critic to executioner. Because Garwin had decided that a result this influential, propped up by an error this clear, could not be allowed to stand on politeness. So, at the 5th Cambridge Conference on Relativity, held at the Massachusetts Institute of Technology in June of 1974, Garwin stood up and dismantled Weber in public. He laid out the errors, and then, in front of the assembled field, he offered to sit down and let the matter rest if Weber or Douglas would stand and admit the mistake. Neither one stood, and the confrontation that followed has become legend in physics. The two men squared off, voices rising, the encounter sliding towards something physical. Two grown physicists in postures that genuinely looked like they might come to blows in an academic conference hall. What separated them was not a security guard, it was an old man's cane. The session was chaired by Philip Morrison, the brilliant MIT astrophysicist, who had been left disabled by polio and walked with crutches. And Morrison physically held up his cane between the two men to keep them apart. That image is the truest picture of the moment Joseph Weber lost his standing in physics, not a quiet correction in a journal. Two men nearly fighting, held apart by a polio survivor's cane, while a field that had idolized one of them 3 years earlier watched him refuse to fall. After that, the consensus closed fast. By 1975, the working assumption across the field was that Weber's detections were not real, that they were artifacts of his analysis, and the energy and replication problems had been there all along to back that up. Weber eventually removed himself from the data analysis, hoping to answer the accusations of bias by stepping away from the part of the process where bias could enter. It made no difference. The verdict was in. And this is the moment where the story could have ended, where Weber could have been a footnote, the cautionary tale every graduate student gets told about fooling yourself. He was nearly fired from the University of Maryland. His funding began to evaporate. The field moved on without him. And it moved on, with an irony so sharp it is hard to look at, precisely toward the goal he had defined, using the field he had created, while treating him as an embarrassment to be managed. But here is the thing that makes Weber more than a cautionary tale. The thing that keeps this from being a simple story about a man who fooled himself. He never stopped. For the next 25 years, with almost no support, with his reputation in ruins, with the entire community certain he was wrong, he kept building, kept refining, kept listening. And the question that should sit uncomfortably in your chest is not whether he was wrong about the detections. He almost certainly was. The question is what it costs a human being to spend the last third of his life listening for a sound that everyone he respects has told him is not there, and to keep hearing it anyway. To understand what those years cost him, you have to meet the person who shared them, because she is the emotional center of everything that comes after, and because her presence in this story ends it with a sentence that I have not been able to shake. In 1970, at a conference, Joseph Weber met an astronomer named Virginia Trimble. She was 28. He was 51, married at the height of his fame. By her own account, he royally snubbed her, brushing off a question she asked, the famous man with no time for the young researcher. That is how they met. It should have ended there. But in July of 1971, Weber's first wife, Anita, whom he had married in 1942, and with whom he had 4 sons, died, and in his grief the famous man wrote to the young astronomer he had snubbed. They had spent, by the time they married, a cumulative total of about 3 weekends together. They married on the 16th of March, 1972. She called him Weber. He called her Trimble. From 1973 on, he spent half of every year at the University of California at Irvine, where she was on the faculty, splitting his life between the Maryland lab and the California campus, where her career was rising as his was beginning its long collapse. And Weber said something to Harry Collins, the sociologist, about that collapse that I think tells you more about the man than any equation. He said, with a smile, that when he married Trimble, he was famous and she was not, and that now their roles were reversed. He could joke about it, the most painful inversion of his life, the slow trading of his fame for her ascent, and he could name it out loud and smile. Kip Thorne, who knew them both and who is about to become one of the most important figures in this story, said of Weber and Trimble simply this: he idolized her. He understood how brilliant she was. To him, she was the most important person in the world. Hold the geometry of that marriage for a moment, because it is one of the quietly remarkable arrangements in the history of science, and almost nobody knows it exists. For nearly 30 years, 2 working scientists kept 2 careers on opposite sides of the country and refused to let the distance end the marriage. He spent half of each year in Maryland and half in California. She did the reverse. They called each other by their surnames, Weber and Trimble, a small running joke that was also a kind of statement. 2 professionals who had found each other late and met as equals and never quite stopped addressing each other as colleagues even in love. And the arrangement meant that Virginia Trimble had a front row seat to the longest and slowest part of the tragedy. The part that has no drama in it, the part that the story of the cane and the conference always skips. She was there for the decades. She watched a man who had been on magazine covers become a man who paid for his own laboratory out of pocket. She watched the invitations stop coming. She watched him keep going to the bunker anyway, year after year, certain. And she was an astronomer. She understood the evidence against him as well as anyone, and she loved him. And she had to hold both of those things at once for 28 years. That is a harder thing than any equation in this entire story. To know, professionally, that the person you love is very probably wrong about the one thing he has staked his life on, and to watch him stake it anyway, and to keep loving him through it without either lying to him or abandoning him. When she finally answered the reporter's question with the words "I do not know," those 3 words were not evasion. They were the distilled residue of nearly 3 decades of standing in the exact place where loyalty and honesty pull in opposite directions and refusing to let go of either one. Most people, asked to live in that contradiction for a weekend, would flee it. She lived in it for the length of a marriage, and she was still living in it, in a front row seat, on the day the universe finally rang. So picture the geometry of his exile, because it was not abstract. By the late 1970s and into the 1980s, the field had rendered its verdict, and Weber's life narrowed to a single building. His laboratory was a low concrete box, a windowless bunker, set in the woods near the University of Maryland golf course, down a hilly gravel road. He kept it running himself. When the funding dried up, he paid for it out of his own pocket. He was, in the most literal sense, both the head scientist and the janitor of his own laboratory. Sweeping the floors of the building where he listened for a sound the rest of physics had agreed did not exist. A Baltimore newspaper ran an article about him in those years, and the headline did not soften it. It called him a pioneer researcher into gravity waves who was now a pariah in the field. He read that about himself. Pariah, and his own summary of the situation, which he gave to a reporter, had a terrible flatness to it. "We are number 1 in the field," he said, "but I have not gotten funding since 1987. I want to stop here for a moment, because there are 2 ways to read a man in that bunker, and they are not the same, and the channel of least resistance is to pick the comfortable one. The comfortable reading is that he was a deluded old man, sweeping the floor of a temple to a god that was not there, and that his persistence was pathology. I do not think that is the honest reading, and I have gone back and forth on it more than I expected to, because here is the uncomfortable fact that the comfortable reading has to ignore. He was right about the thing that mattered most. Gravitational waves are real. The universe does ring. He was wrong about whether his particular machine had heard it. Badly wrong, provably wrong, but the entire premise that the rest of the field eventually built $1 billion empire on, the premise that these waves exist and can be caught by a human instrument, was the premise Joseph Weber had defended alone. Against Einstein's own published doubt, against a field that called detection impossible, when literally no one else on Earth was willing to try. Strip away the false detections, and there is still a man who was correct about the deepest question, kept the faith through 25 years of humiliation, and was treated as a fool for believing the one thing that turned out to be true. The tragedy is not that he was wrong. The tragedy is that he was wrong and right at the same time, in different ways, and the world only ever measured him on the wrong one. And the cruelty of it sharpens when you trace where the field actually went. Because it did not abandon his dream, it abandoned him and kept his dream. Every piece of the technology that finally succeeded traces a clean line back through Joseph Weber, and the people who built it have never pretended otherwise. The first response to the thermal noise problem that crippled his room temperature bars was the obvious one. Cool them. If random heat is what makes the atoms jitter, then chill the bars toward absolute zero, and the jitter quiets down. Through the 1980s and 1990s, a generation of cryogenic bar detectors with names like Explorer, Nautilus, Auriga, and Allegro ran in Italy, in Louisiana, in Australia, cooled to within a few degrees of absolute zero, far more sensitive than anything Weber built, direct descendants of his cylinder. They were serious instruments, and they ran for years. They also never detected a gravitational wave, because even cooled to the edge of absolute zero, a resonant bar listens at essentially one frequency, and the universe does not always sing in that key. The bar was a dead end as a destination, but it was not a dead end as a beginning. It was the thing the field had to build and exhaust before it would commit to the radically harder idea that would actually work. And that idea, too, ran through Weber's own laboratory, which is the part that should genuinely take your breath away. In Weber's notebooks were sketches and ideas for a completely different kind of detector, one that did not rely on a resonant bar at all. One that would instead bounce laser light back and forth between mirrors and watch for the minute change in the time it took the light to travel as a gravitational wave stretched the space between them. An interferometer. One of Faber's own students, a physicist named Robert Forward, who would later become a successful science fiction novelist, built one of the very first laser interferometer gravitational wave detectors at Hughes Research Laboratories. The seed of the machine that would win the Nobel Prize was planted in the lab of the man the field had cast out. But the person who took that idea and made it rigorous, who calculated in cold detail that a laser interferometer with arms kilometers long could in principle reach the strain sensitivity of 1 part in 10 to the 21 that the real waves demanded, the sensitivity that Weber's bars missed by a factor of 100,000, was a quiet-mid physicist named Rainer Weiss. In the early 1970s, while Weber was at the peak of his fame and the start of his fall, Weiss worked out the full design in a now famous internal report, identifying every source of noise that would have to be defeated. And the third figure, the one who connects the whole thing back to the beginning with a detail that I find almost too neat to be real, was Kip Thorne. Thorne, the Celtic theorist who would share the 2017 Nobel Prize, decided to devote his career to gravitational waves after long conversations with Joseph Weber in 1963 before any of the detections, before the fall, when Weber was simply the one man in the world who believed this was worth a lifetime. The founding father did not just inspire the field in the abstract. He personally, in conversation, set the course of one of the 3 men who would eventually be honored for finishing what he started. Therefore consider what the year 1987 actually was, the year Weber said his funding ended, because the timing is not a coincidence, and it is the single most bitter fact in this entire story. Weber's money did not simply run out. It was redirected. The National Science Foundation, the body that funds American physics, was at that moment making the decision to commit to the largest, most expensive, most ambitious project it had ever undertaken in the physical sciences. A pair of laser interferometers, each with 2 arms 4 kilometers long, one in Washington state and one in Louisiana. A machine that would eventually cost well over $1 billion and take nearly 3 decades to bring to fruition. The Laser Interferometer Gravitational Wave Observatory, LIGO, the field that Joseph Weber created, was, in the very years, it was letting him sweep the floor of his own bunker, persuading the United States government to spend more than $1 billion chasing the exact thing he had been chasing all along. They cut the founder's funding and used the room in the budget to build his dream 1,000 times larger. He was not invited to join. His wife later said she thought he would have declined if asked. But the deeper truth is that the question of asking barely arose. The field had decided he was a liability, and you do not put the man your enterprise is quietly embarrassed by on the masthead of your flagship. And the project they built instead was so difficult that for years it was not at all clear it would work, which is its own kind of vindication of how impossibly hard the thing Weber attempted really was. The numbers involved in LIGO are the kind that stop making sense the longer you look at them. To detect a strain of 1 part in 10 to the 21 across an arm 4 kilometers long The machine has to measure a change in that arm's length of about 1 part in 10,000 of the width of a single proton. Not a proton, a 10,000th of a proton. To put that in human terms, the proportional sensitivity is like measuring the distance to the nearest star, 4 light years away, and being able to detect a change in that distance smaller than the width of a human hair. The mirrors at the ends of the arms had to hang in near perfect stillness while the entire restless Earth shook around them, with its earthquakes and its ocean waves and its traffic and its weather. The light had to be the purest, most stable laser light ever produced. The vacuum in the tubes the light traveled through had to be one of the largest and emptiest artificial vacuums on the planet. For years, distinguished physicists argued that the whole thing was a fantasy, that it would never reach the sensitivity required, that it was a billion-dollar bet on an instrument that might detect nothing but the trembling of its own components, which, if you are keeping track, is precisely the accusation that had been leveled at Joseph Weber. The difference is that LIGO survived the accusation, and it survived it the only way such a thing can be survived, by taking decades and more money than anyone wanted to spend and refusing to die through round after round of doubt. The project was nearly killed in Congress more than once. It was, for a long stretch in the 1990s, the single most expensive project the National Science Foundation had ever funded, and there were respected physicists who considered it a reckless gamble that would swallow the budget of an entire scientific generation and return nothing. They built it anyway. They poured the concrete for 2 L-shaped detectors with arms 4 kilometers long, in the desert of eastern Washington and in the swamp of Louisiana, and then they ran an entire first version of the machine, called Initial LIGO, for years, from 2002 onward, and it detected exactly nothing, because everyone involved understood that the first version was never sensitive enough to succeed. It was a practice run that cost hundreds of millions of dollars, a deliberate failure undertaken so that they could learn how to build the real thing. Then they tore much of it out and rebuilt it as advanced LIGO, more sensitive by an order of magnitude, and that is the machine that finally caught the wave. Think about what kind of patience that requires, what kind of institutional faith to spend a decade building something you know in advance will fail, in order to learn how to build the thing that might not. It is the exact patience Weber was never given. He got one career, one budget, one lifetime. And when his first instrument failed to convince, the field did not say, "Let us build him a better one and try again." It said, "Let us build a better one, and let us build it without him." The project nearly tore itself apart in the process. Ronald Drever, the Glasgow physicist whose own bars had returned the null results that helped sink Weber, had moved to Caltech and become one of LIGO's 3 founding figures alongside Weiss and Thorne. And Drever was a brilliant, intuitive, difficult man whose clashes with the project's management became so severe that he was eventually forced out of the leadership of the very experiment he had helped create. It took the arrival of a physicist named Barry Barish, a manager of rare ability, to turn a feuding academic project into the disciplined engineering enterprise that could actually deliver. There is a pattern here that should be starting to feel familiar. The field that does this work seems unable to do it without grinding up the people who care about it most. And Drever, like Weber before him, would not make it to the end of the story whole. He developed dementia. He died in March of 2017, months before the Nobel Prize he would surely have shared was awarded. And the Nobel is never given posthumously, so his name is not on it. The field has a way of arriving at its triumphs a step too late for the people who made them possible. I keep using the word vindication, and I want to be honest about how slippery it is, because this is the place in the story where the comfortable version and the true version finally split for good. and the difference between them is the whole point of telling it. When LIGO finally succeeded, the headline said Einstein was proven right, and that is true. Some people, looking for a tidier story, wanted to say Weber was proven right too, that the old man in the bunker had been vindicated at last. And that is where you have to be careful, because it is not true, and pretending it is true does a disservice both to the facts and, strangely, to Weber himself. LIGO did not prove that Weber's bars had detected anything. The overwhelming weight of evidence is still that they did not, that his signals were noise, that the 4-hour coincidences and the fake-injected pulses he detected were exactly what they appeared to be. LIGO worked at a strain 100,000 times fainter than anything a Weber bar could reach, using a completely different technology, detecting a completely different kind of source than the galactic center radiation Weber claimed. Nothing about the 2015 detection rescues the 1969 detection. They are not the same claim, and one does not redeem the other. What LIGO vindicated was something larger and stranger than Weber's data, and it is the thing I think actually matters. It vindicated the bet. It proved that the phenomenon Joseph Weber gave his life to was real, that gravitational waves exist, that they can be caught by a human instrument, that the whole enterprise he founded when Einstein himself had wavered, and the rest of physics called it impossible, was not a fool's errand, but the most important kind of errand there is. He was wrong about the catch, and right about the existence of the thing to be caught. He was wrong in the particular, and right in the general. And if you have ever been certain of something important and then been told, by everyone you respect, with mounting evidence, that you were wrong, you know that those two kinds of being right do not feel different from the inside. They feel identical, which is exactly the problem the people at LIGO were so afraid of that they did something almost unbelievable to protect themselves from it. And to understand the night the universe finally rang, you have to understand what they had built specifically to keep from becoming Joseph Weber. They built a system of blind injections. The LIGO collaboration knew, better than anyone alive, how easy it is to find a signal you badly want to find. The entire history of their own field was a monument to that danger, and his name was Weber. So they gave a tiny, secret group of people the power to artificially inject a fake gravitational wave signal directly into the detectors. A phantom event, engineered to look completely real, without telling the hundreds of scientists analyzing the data whether any given signal was real or planted. The analysts would chase a detection all the way to the edge of announcing it to the world, write the paper, prepare to publish, and only at the final moment would the envelope be opened to reveal whether they had caught the universe or caught themselves. They had done exactly this in 2010, run a signal they nicknamed the Big Dog all the way to a finished, ready to submit paper, before being told it was a blind injection, a fake, planted to test whether they could be fooled. They were building, at a cost of more than $1 billion, an elaborate institutional machine whose entire purpose was to force themselves to confront, on every single candidate signal, the question that Joseph Weber could never bring himself to answer. Are we detecting the universe, or are we detecting our own desire to detect the universe? That is the inheritance Weber left the field that exiled him, not a technology, a fear, the permanent, structural, institutionalized fear of becoming him. And so when the real signal finally arrived, in the early morning hours of the 14th of September 2015, the very first thing the scientists thought was not, "We did it." The first thing many of them thought was that it was too good, too clean, too perfect, and that therefore one of their own colleagues must have planted it. But Joseph Weber was not in that control room to fear it or to hope for it. He was not anywhere. He had been dead for almost 15 years, He died on the 30th of September, 2000, at the age of 81, and the manner of it has the same terrible irony that ran through everything else in his life. In his final years, he was still going to that concrete bunker in the woods, still running the lab he could no longer fund, an old man walking down a hilly gravel road to listen for the universe. And one day, he slipped on the ice on that road. He fell and hit his head and was found unconscious. He had been diagnosed some 3 years earlier with lymphoma, a cancer of the immune system, and during his recuperation from the fall, his broken bones slow to heal in a body in its 9th decade, the cancer came back. He died in Pittsburgh, undergoing treatment, far from both the Maryland bunker and the California campus that had been the two poles of his divided life. The man who survived the sinking of an aircraft carrier in the Pacific in 1942, who outlasted the destruction of his reputation, who endured 25 years of being called a pariah, was finally undone by a patch of ice on the road to his own laboratory. And he died believing. That is the fact that everything else has to be measured against. He went to his grave, certain that he had detected gravitational waves, certain that the bars had rung with the death of stars, certain that the field which had cast him out was wrong, and that history would prove him right. He had been told for a quarter of a century, by the most accomplished physicists alive, with replication failures from 3 continents, and an energy argument that bordered on a law of nature and a 4-hour timing error that should have been the end of it, that the signal was not there, and none of it moved him. Some part of you wants to call that stubbornness, and some part of you wants to call it integrity, and the unbearable thing is that from the inside to the person living it, those two are indistinguishable. They are the same posture. The refusal to abandon a belief in the face of mounting evidence is the worst sin a scientist can commit, and also the exact thing that every scientist who was ever vindicated against an entrenched consensus had to do. Weber did it and was wrong about the detections. He also did it and was right about the waves. The same trait, pointed at 2 different questions, made him both a fool and a founder, and there was no moment in his life where he could have known which one he was being. I said near the beginning that Weber had a gift for being early, and that being early in science can be worse than being wrong, and I want to close that loop now because his death is where it finally tightens. Look at the full shape of the man's career. The cosmic microwave background, lost to a single no from Gamow, discovered by others a decade later. The mesa, described by him, the Nobel given to other names in 1964. And gravitational waves, the field he founded, the dream he defended alone, the Nobel awarded in 2017 to Weiss and Thorne and Barish, 17 years after his death. 3 times he stood at the doorway of the most important discoveries of his century, and 3 times the recognition formed around someone else. He was a man perpetually 1 step ahead of the moment that would have honored him, and being ahead of that moment, it turns out, is not a blessing. It is a way of spending your whole life in a room that everyone else will eventually move into after you are gone, and decorate and call their own. The cruelty of being early is that you do the hardest part, the believing when there is no proof, and you do not get to be there for the part where the believing is finally easy. And here is the foreshadow I planted at the very start, returning now with all the weight it has gathered. Because we are close to the bottom of this, and you can probably feel it coming. I told you that from the inside, a real detection and a complete delusion feel exactly the same, that the universe does not send a receipt. Sit with what that actually meant for the last 25 years of Joseph Weber's life. Every night in that bunker, he was hearing something. The data really was spiking. The bars really were ringing. He was not lying, and he was not hallucinating. He was looking at real fluctuations in a real instrument, and reading meaning into them. The same act, the precise same act, that the LIGO team would perform in 2015 when they looked at a real fluctuation in their instrument and read meaning into it. The difference between Weber and LIGO was not the sincerity of the listening. It was not even the certainty. It was that one of them was hearing the universe and one of them was hearing himself, and there was nothing available to either of them in the moment of listening that could have told them which was which. The confirmation did not live in the data. It never does. It lived in something outside the data entirely, in replication, in consensus, in a billion-dollar machine built 3 decades later by people who were terrified of making his mistake. Weber could not access that confirmation because it did not exist yet. He was asked to know alone in real time a thing that can only ever be known collectively, afterward, sometimes long after you are dead, and he answered the only way a human being, under that impossible demand, can answer. He believed what he wanted to be true, and he called it the universe. That is not a flaw peculiar to Joseph Weber. I want to be very clear about this, because it is the thing the whole story has been walking toward, and it is the reason this is not a comfortable little parable about a bad scientist who fooled himself while the good scientists got it right. The good scientists were one blind injection away from announcing a fake. They knew it. They built the injection system precisely because they knew that they, too, with all their rigor and all their $1 billion, could be Weber on any given night, could look into the noise and see exactly the cathedral they had spent their lives hoping to find. The line between them and him was not a line of character. It was a line of timing and machinery and the slow social labor of 1,000 people checking each other. Remove those and they are him. Remove those and you are him. The capacity to mistake your own hope for a signal from reality is not a defect in unusually weak minds. It is the standard equipment of the human one, and the only thing that has ever reliably corrected for it is other people, and time, and the universe occasionally being kind enough to ring so loudly that no analysis on Earth can pretend it is silence. In 2015, for the first time, it rang that loudly. It happened at 50 minutes and 45 seconds past 9 in the morning, Coordinated Universal Time, on the 14th of September, 2015. Both LIGO detectors, the one in Hanford, Washington, and the one in Livingston, Louisiana, separated by about 3,000 kilometers, registered the same thing within 7,000ths of a second of each other. Exactly the light travel time between them. Exactly the fingerprint of something sweeping through the whole planet from outside. And the signal was not the faint, buried, statistically tortured whisper everyone had expected to fight for. It was loud. It was so clean that physicists looking at the raw data could see it with their eyes, the shape of it rising right up out of the noise, which after 50 years of this field's history was almost the most shocking part of all. A postdoctoral researcher in Hanover, Germany, named Marco Drago, was one of the first human beings to see it come through, and the collaboration's instinct, drilled into them by a decade of blind injection drills, was immediate and reflexive. They assumed it was fake. They assumed someone had planted it. It took weeks of checking, confirming that no injection had been made, that no test was running, before they would let themselves believe that what they were looking at was not a drill. It was the thing itself. That reflex, the instant assumption that the signal of the century was a fake planted by their own colleagues, did not come from nowhere. It came from a wound the collaboration had given itself on purpose 5 years earlier. In the autumn of 2010, the detectors had registered a candidate event, a signal that appeared to come from a source in the direction of the constellation Canis Major, and the team nicknamed it the Big Dog. They analyzed it for months. They became increasingly convinced it was real. They wrote a discovery paper, a complete manuscript, announcing the first detection of gravitational waves, and they took a formal vote to approve it for publication. And only then, with the paper written and the vote taken and the champagne all but poured, was the envelope opened and the truth revealed. The big dog was a blind injection. It had been secretly planted in the data by a tiny authorized group for the express purpose of finding out whether the collaboration could be fooled into announcing something that was not there. They could. They almost did. The most rigorous gravitational wave scientists on the planet had walked their own discovery all the way to the edge of the cliff, propelled by exactly the same engine of hope and pattern recognition and desire to succeed that had driven Joseph Weber into his bunker. And the only thing that stopped them from going over was an institutional trick they had played on themselves, precisely because they did not trust that engine. So when the real signal arrived in 2015, the muscle memory of the big dog fired instantly. Their first thought was not triumph. It was, again, someone is testing us. It took them weeks to accept that this time, no one was. What they had caught was an event that took place about 1,300,000,000 years ago, when the most complex life on Earth was still single cells in the ocean. 2 black holes. One with a mass of about 36 times the mass of our Sun, and the other about 29 times, had been locked in a death spiral, orbiting each other faster and faster, thousands of times a second at the end, until they merged into a single black hole of about 62 solar masses. Do the arithmetic on those numbers. 36 plus 29 is 65. The final black hole was 62. About 3 solar masses had gone missing. 3 entire stars worth of mass vanished, converted directly into the energy of gravitational waves in a fraction of a second, radiated out across the universe as a violent shudder in the shape of space-time itself. And in the final instant of that merger, that single event briefly radiated more power in gravitational waves than the combined light of every star in the entire observable universe. More power than every sun in every galaxy that exists, all of them together. For that one fractional moment, poured out not as light, but as a ripple in the geometry of reality. And a tiny, tiny, almost nothing fraction of that ripple, after traveling for 1,300,000,000 years, reached the Earth and stretched the 4-kilometer arms of 2 laser detectors by about 1/10,000th of the width of a proton. The signal swept upward in pitch from about 35 vibrations per second to about 250 in 2/10ths of a second as the black holes spiraled in and merged. And that detail is the one that closes the circle of this entire story, because that frequency, 35 to 250 cycles per second, is in the range of human hearing. The collaboration converted the gravitational wave signal directly into a sound, and you can listen to it. It is a chirp, a short, rising whoop, the sound of 2 black holes becoming one. The actual vibration of space-time translated into a pressure wave your ears can register. After all of it, after Einstein's doubt and Weber's bars and the 4-hour error and the cane held up at Mitt and the bunker in the woods and the $1 billion and the 50 years, the universe rang, and the ringing was made audible, and it lasted about 1/5 of a second, and it sounded like a bird. The result was published in Physical Review Letters, volume 116, on the 11th of February, 2016, under the flat, enormous title, Observation of Gravitational Waves from a Binary Black Hole Merger. The statistical significance was beyond 5 standard deviations, with a false alarm rate estimated at less than 1 event in 203,000 years. There was no room left for the experimenter's regress, no room left for the question that had haunted the field since Weber. This was not one laboratory story about itself. It was 2 detectors, 1,000 scientists, a decade of guarding against self-deception, and a signal you could see by eye and hear with your ears. In 2017, the Nobel Prize in Physics went to Rainer Weiss, who received half, and to Kip Thorne and Barry Barish, who split the other half, for decisive contributions to the LIGO detector and the observation of gravitational waves. The citation did not mention Joseph Weber. It did not need to. Every person on that stage knew whose field they were standing in. And in the front row of the press conference on the 11th of February, 2016, where the discovery was announced to the world, sat a 73-year-old astronomer named Virginia Trimble. She had been invited personally by Franz Cordova, the director of the National Science Foundation, the same agency that had cut her husband's funding in 1987 to pay for the machine whose triumph she was now watching. Weber's widow, in the front row, at the vindication of the dream that had cost him everything and that he had not lived to see. There is a detail about the timing that I almost did not include because it sounds invented, but it is real. The signal arrived in the middle of September 2015, around the Jewish New Year, Rosh Hashanah, and near the anniversary of Weber's death. The universe rang for the first time in human history within days of the season that marked 15 years since the man who founded the search for it had slipped on the ice and begun to die. A reporter from the journal Science asked Virginia Trimble the only question that mattered. Did she believe that her husband had really detected gravitational waves back in the 1960s with his bars? She was an astronomer. She knew the evidence. She knew the energy argument and the replication failures and the 4-hour error as well as anyone alive. She had also spent 28 years married to the man, had watched him sweep the floor of his bunker, had heard him insist until the end that he had been right. And her answer was 3 words. I do not know. Not yes, out of loyalty. Not no, out of rigor. I do not know. She also said, about the whole arc of it, damn it, it is devastating. I am sorry. And she said something that I think is the wisest thing anyone has said about the entire affair. She said that if the National Science Foundation had funded both Weber's bars and LIGO, instead of killing one to feed the other, the 2 efforts would have pushed each other forward as collaborators rather than competitors, and the discovery might have come sooner. The tragedy, in other words, was not inevitable. It was a choice. Somebody decided there was room for the dream, but not for the dreamer. I could end the story there, on a widow, in a front row, saying 3 honest words, and it would be a complete story about science and pride and the price of being early. But it would let you off too easily, because it would let you treat this as something that happened to other people, to physicists, to a strange driven man in a bunker, safely sealed off from your own life. And it is not sealed off from your own life. The implications of what LIGO confirmed reach all the way to the body you are sitting in right now. And once you see how far they reach, the story stops being about Joseph Weber and starts being about you. Since that first detection in 2015, LIGO and its partner detectors have caught the universe ringing again and again, dozens of times. Black holes merging, neutron stars colliding, a steady catalogue of cosmic catastrophes, each one a confirmed gravitational wave event. And every one of those detections is telling you something that does not stay politely inside the laboratory. It is telling you that these waves are not rare. The ones loud enough for us to catch are rare. The waves themselves are not. The universe is full of them, a constant churn of merging dead stars and spiraling black holes across billions of galaxies, every one of them sending out ripples that spread forever and never fully die. At this moment, as you take in these words, gravitational waves from countless events you will never know about are passing through the room you are in. They are passing through the walls as if the walls were not there. They are passing through the earth as if it were not there. And they are passing through you. Understand what that means physically, because it is not a metaphor. A gravitational wave does not bounce off you or get absorbed by you. It passes through you, and as it passes, it changes the distances inside your body. The space between two atoms in your hand is, right now, being very slightly stretched and squeezed by waves arriving from the collisions of objects that died before the Earth existed. The effect is unimaginably small, far smaller than a proton across the whole width of your body, which is exactly why you feel nothing. But the not feeling is the point. You are being rung. You are a bell that the universe is striking, continuously, with the energy of dying stars, and you will go your entire life without registering a single note of it. Joseph Weber built a 2-ton cylinder of aluminum and cooled it and shielded it and wired it with crystals in a desperate attempt to feel a tremor that your own body is too crude an instrument to ever notice. And his machine, for all its inadequacy, was still 1,000 times more sensitive than you are. So consider the reframe, because it inverts everything the popular story told you. The lesson of Joseph Weber is not that he heard a ringing in a universe that was silent. That is the comfortable version, the version where he is simply deluded, hearing ghosts in an empty cosmos. The truth is stranger and worse. The universe was ringing the entire time. It has never once been silent. For the whole of human history, for the whole of life on Earth, the death screams of black holes have been washing through every cell of every living thing, a constant trembling in the fabric of space that no creature ever felt. Weber was right that the ringing was there. His error was almost unbearably precise. He heard the real ringing of the universe everywhere except where it actually was, and located it instead in the one place it was not, in the thermal noise of his own apparatus, while the genuine waves passed through his body and his bars and his bunker unheard. The way they pass through you. He spent 40 years listening for a sound that was, in fact, all around him, and the cruelty is that the version he could hear was the only false one. And even now, even with LIGO, we are barely less deaf than he was. We catch the loudest events, the largest black holes, the closest collisions, the rare catastrophes violent enough to shout across 1 billion light years and still move our mirrors by a 10,000th of a proton. Everything quieter than that, which is to say almost everything, slips past uncounted. There is thought to be a continuous background hum of gravitational waves from all the mergers too distant or too faint to resolve, a stochastic sea of trembling spacetime that we are only just beginning to strain to hear. We are a species that existed for hundreds of thousands of years without the faintest idea that we were living submerged inside a sound, and that only in the last decade of those hundreds of thousands of years built an ear delicate enough to catch the loudest fraction of 1% of it. We are not the listeners the universe has been ringing for. We are latecomers who just learned the room was never quiet. And being a latecomer to the sound is not even the part that should unsettle you most. The part that should unsettle you most is what the whole affair reveals about how any of us, scientist or not, ever come to believe that something is real. Because the reason 2015 ended the argument was not that the LIGO team was wiser or more honest than Joseph Weber. It was that the universe, for once, was generous. It sent a signal so enormous, 2 black holes of 36 and 29 solar masses colliding close enough and loud enough that the chirp rose visibly out of the noise, and no human judgment was required to see it. The data did the convincing. But that generosity is the exception, not the rule. Most of what is true about the universe does not arrive at 5 standard deviations with a sound you can play through a speaker. Most of it arrives the way Weber's waves arrived, faint, ambiguous, buried in noise, requiring a human being to look at a smudge of data and decide what it means. And in that situation, which is the normal situation, which is almost every situation, there is no receipt. There is only a person looking at noise, deciding what to believe. Here is the thing I genuinely cannot get past. The thing that I think is the real and permanent disturbance underneath this entire story. The feeling of being right is generated entirely inside your own head, and it is exactly the same feeling whether you are right or wrong. Weber felt the certainty of a man who had detected gravitational waves. He was wrong. The LIGO team, on the night of the Big Dog blind injection in 2010, felt the certainty of people who had detected gravitational waves, wrote the paper, prepared to publish, and they were also wrong, because their colleagues had planted it to test them. 2 groups, both certain, both mistaken, and the certainty in both cases was indistinguishable from the certainty that turned out, 5 years later, to be correct. The internal sensation of truth is not connected to truth. It is connected to nothing but itself. It is a feeling, and the universe does not check your feelings against reality and send back a correction. You have to do that yourself. And the brutal discovery of the gravitational wave field is that you cannot do it yourself, not reliably, not alone, because the same mind that holds the belief is the mind that would have to judge it. And that mind is compromised by the very fact of holding the belief. Sit with what the LIGO collaboration actually did about this, because I think it is one of the most quietly profound things any group of human beings has ever done, and it is usually told as a technical footnote. The best experimental physicists in the world, working on the most important measurement of their century, did not trust themselves. They knew that their own desire to succeed was a contaminant in the instrument as real as any vibration or any stray photon. So they built, deliberately, at great expense, a system to deceive themselves. They gave a handful of people the power to inject convincing fakes into the data, and they kept everyone else in the dark about whether any given signal was real, so that the collaboration would be forced, on every candidate event, to chase it all the way to the brink of belief before being allowed to know whether they had been fooled. That is the most rigorous act in the history of science, and it is also the most frightening confession the human species has ever made about its own mind. It is 1,000 brilliant people saying, out loud, in the architecture of their experiment, we do not trust our own certainty. We have to be tricked into doubting ourselves, because left to our own devices, we will see what we hope to see, every time, and we will call it the universe. Now turn that on yourself, because it does not stay confined to physics, and this is the place where the story finally arrives at you. You do not have a blind injection system. You have never had one. Every belief you hold with real conviction, every certainty about your work, your relationships, your sense of how the world is arranged, the things you are sure you have figured out, you hold all of them the way Joseph Weber held his bars. From the inside, your true beliefs and your false ones feel identical, because the feeling of certainty is manufactured in the same place by the same process, regardless of which kind it is. You have no internal instrument that lights up for truth and stays dark for delusion. Nobody does. The only thing that has ever reliably told the difference across the entire history of human knowledge is the slow, external, social, sometimes merciless process of other people checking your work and time passing and reality occasionally being kind enough to ring loudly enough that the question settles itself. And that process is slow, and it does not care about your schedule. And sometimes, As it did for Weber, it delivers its verdict to an empty bunker, or to a hospital room in Pittsburgh, or to a grave that the truth arrives at 15 years too late. I want to say something now that I think the polite version of this story works very hard to avoid, because the polite version needs the scientific community to come out of this looking wise, and I do not think it should. The field was right to reject Weber's detections. I want to be completely clear that the rejection itself was correct, that the replications mattered, that the energy argument was sound, that the 4-hour error was real and damning, and that a discipline which accepts unreproducible results is not a discipline at all. The skepticism was not the crime. The skepticism was science working exactly as it should. The crime was something separate and quieter, and it is the thing that should make you angry. The field needed Weber to be wrong about his detections, and he was. It did not need him to become a pariah, and it made him one anyway. Those are two different things, and the second one was a choice, made by committees and grant panels and colleagues, to take a man who had been wrong about a measurement and treat him as though he had been wrong to exist. Look at the sequence of it, because the sequence is the indictment. While he was alive and could have used it, they withheld the funding in 1987 to build his dream without him. While he was alive and could have heard it, they withheld the credit, leaving him to tell a reporter that his lab was number one in a field that would not pay for it. While he was alive and could have felt it, they withheld the simple respect of a place at the table of the enterprise he had founded. And then he died. And only then, when it cost nothing, when there was no risk that honoring him might be mistaken for endorsing him, the honors began to arrive. There is now a Joseph Weber Award for Astronomical Instrumentation, given by the American Astronomical Society. There is a Weber Memorial Garden at the University of Maryland, dedicated in 2019. One of his original bars is on display at the LIGO Observatory in Hanford, the very project his funding was killed to create. The cylinder sitting there like a relic, like a saint's bone, venerated by the cathedral that excommunicated him. Count them: an award, a garden, a museum piece, and the same reverent sentence in the mouth of every founder of the field. Kip Thorne, standing in the glow of his Nobel Prize, said it plainly. He really is the founding father of this field. Charles Missner, dedicating the garden, said that before Weber. He did not think anyone had ever spent more than 10 minutes trying to figure out how to detect gravitational waves in a laboratory, and that without him it might have been another century before anyone discovered them. These are not small tributes. They are true, and they are generous, and every single one of them arrived after the man was in the ground and could not be helped by them. The field found its love for Joseph Weber at the precise moment that love became free. And there is a parallel here that I do not think is an accident, because it tells you that what happened to Weber was not a freak event, but a feature of how this particular knowledge gets made. Go back to Einstein in 1936, sending his paper to Physical Review, certain that gravitational waves did not exist, and being told by an anonymous referee that he was wrong. Einstein was furious, withdrew the paper, and never published in that journal again. Exactly the reaction of a great man told he has earread. But Einstein, crucially, looked again. He let his assistant walk him through the argument. He saw the mistake, and he reversed himself before the error reached print. The same review process that humiliated him also saved him, and because he submitted to it, he was wrong only in a withdrawn draft instead of wrong in history. Weber faced the same machinery, the same skeptical community, the same demand to look again at a result he was sure of, and he made the opposite choice. He did not reverse, he held. And the difference between the two men is the difference between an error caught in a drawer and an error carried to a grave. The machinery was the same in both cases. It is genuinely good at catching mistakes. What it has never been good at, what it may not be capable of, is catching the mistake without breaking the person who made it, and deciding, while there is still time to matter, which of the two it is dealing with, a stubborn fool or an early prophet, when from the outside, just as from the inside, the two look exactly the same. Because that was always the unanswerable problem at the center of Joseph Weber. The same refusal to back down that made him wrong about his bars was the refusal to back down that made him right about the waves when Einstein himself had wavered and the whole field called it impossible. You cannot separate the two. They are one trait. The man who would not abandon a false detection in the face of overwhelming evidence is the identical man who would not abandon a true premise in the face of universal discouragement. And there is no version of Joseph Weber who has the second virtue without the first vice. The field wanted the founder without the fool, the visionary without the stubbornness, and it could not have them separately. Because they were never separate. They were the same stubborn heart, and it beat in a concrete bunker in the woods until the ice took him. So I want to take you back, one last time, to the gravel road in the woods near the Maryland golf course, because everything we have built across this entire story comes to rest there. Picture an old man in his late 70s, then his 80s, walking down that road to a windowless concrete box that the rest of physics has decided is a monument to his own foolishness. He is paying for it himself. He sweeps it himself. Inside, the bars are still suspended, still wired, still listening, and the data is still coming in, and in that data he still sees what he has always seen. The galaxy, ringing, he is not performing for anyone. There is no one left to perform for. The cameras stopped coming decades ago. The funding stopped in 1987. The colleagues stopped believing him by 1975. He is an old man alone with his instrument, reading the universe out of the noise, and he is wrong. And he does not know he is wrong. And there is no possible way for him to find out, because the only thing that could ever tell him will not arrive until 15 years after he is dead. That is the image I cannot put down. Not the confrontation at MIT, not the cane, not the Nobel he never got. Just the old man on the road, certain, alone, and mistaken, walking toward a sound that was not there to listen for a universe that was, in fact, ringing all around him in a register he had located in exactly the wrong place. He had the right faith and the wrong evidence, and he could not separate them, and neither could anyone else, not even the brilliant people who were correct to doubt him, because separating them is the one thing that cannot be done from inside a single human life. It requires more lives than yours. It requires the slow machine of other people, and it runs on a clock that does not care whether you are still alive to read its output. And then, on the ice, in 2000, the clock simply stopped for him. He slipped, he fell. The cancer that had been waiting came back into the broken body, and Joseph Weber died in a hospital in Pittsburgh on the 30th of September, still certain, still unvindicated, still the founder of a field that would not claim him until claiming him was free. He had survived the sinking of the Lexington at the Coral Sea. He had survived 25 years of professional exile. He did not survive the road to his own laboratory. There is no moral in that. It is just the shape the universe happened to make, and the universe, whatever else this story has taught us, does not make shapes for our benefit. 15 years later, on a September morning, the thing he had given everything to finally happened, and I need you to hold the precise cruelty of the timing. 2 black holes that had died before the Earth was formed sent out a shudder in spacetime that traveled for 1,300,000,000 years, crossed the entire history of life on this planet in transit, and arrived at 2 laser detectors that rang unmistakably with a rising chirp that lasted about 1/5 of a second and then was gone. The universe rang, loudly, audibly, exactly as Weber had insisted it could. And it rang within days of the anniversary of his death, and the ripple, on its way to the machines that caught it, passed through the ground where he was buried, the way it passed through everyone, the way it is passing through you. 1/5 of a second, after 100 years of theory and 50 years of failure and 1 ruined life, the confirmation that the universe sings lasted about as long as a single heartbeat, and the man who had bet his existence on it had been gone for 15 years and did not hear a note. His widow, asked whether he had been right all along, said she did not know. And that is the truest possible ending, because it is the only honest one, and it is the same answer the universe gives to all of us about almost everything we are most sure of. I do not know. The waves are real. His detections were almost certainly not. He was the founder of the field and the fool of the field, in the same body with the same heart, and he died in the gap between those 2 facts, which is a gap that never closed and never will, because the thing that would close it, certainty about your own certainty, is the one thing no human being has ever been issued. So here is where I leave you, and I am not going to make it comfortable, because there is no comfort in it that would be true. Right now, as you reach the end of this, gravitational waves from collisions you will never know about are passing through your body and changing the distances inside you by less than the width of a proton, and you cannot feel a single one of them. You are deaf to the loudest events in the universe. Joseph Weber spent 40 years trying to feel what your body cannot, and he heard it everywhere except where it was. And he could not tell the difference between the universe and the empty room, and the part you should carry out of here with you, the part that should sit in your chest tonight, is that you cannot either. Every certainty you hold feels exactly like his felt. The conviction in your own mind is generated by the same machinery, whether it is tracking something real or tracking nothing at all. And there is no light that comes on, no receipt, no signal from reality confirming that you have it right. There is only the slow verdict of other people and of time, and it is in no hurry, and it does not always arrive while you can still hear it. The universe rang. He was right that it rings. He just rang first, alone, in a concrete room, and called the echo the cosmos. And the waves are passing through you as you finish reading this, and you will never feel them, and you will spend the rest of your life unable to be certain which of the things you are most sure of are the universe, and which are only the room.